Number 78, it says that you've got a equation of a line that's negative x plus 3y is equal to 6, right? Now here is one method to do this, right? One method to do this is to say, I'll put it into mx plus b, right? Now that's something that we talked about in that previous lesson too. So what we can do is move the x over and it becomes a positive, and then we can divide everything by 3, and so it becomes y is equal to 1/3 x plus 2. And then we can conclude that the slope is 1/3 and the y-intercept is a 2. All right, so that's a perfectly good way to do it. And then after that, you can go ahead and quickly sketch a graph of this situation. I know that for a fact, based on the last homework and everything, that you know how this works, but, just one last time sort of a thing, because we don't want any awkwardness in pre-calculus about these sorts of things. So we start off, sorry, with the y-intercept, and then we rise 1 unit, right? So I'm going to move up to 3. And then we run 3 units. So from 3, I'm going to run 3 units forward. So here is the line that you should be sketching on your paper. All right? So that is one way to do that question. The reason why, however, I'm going over this is because I want to talk about this secondary way of getting the same job done. And the second way is very useful, actually, right? A lot of people, they say, I'm not going to use this because, it just takes more understanding, but it's very useful in the future. This is basically what you're looking at is the standard form. And in standard form, the quickest way to actually graph a line is to do the following, is to use something called the intercept method. All right, the intercept method. And now in the intercept method, basically what you do is you always are accustomed to a y-intercept, but there's also an x-intercept. And the way that you do it is the following. You basically say, all right, when x is equal to 0, right? When x is equal to 0, negative x plus 3y is equal to 6. And in this situation, the x becomes a 0, right? So if the x becomes a 0, you solve for the y, and you end up with y is equal to 2, right? Because if 3y is equal to 6, divide on both sides by 3, and you end up with 2. So what this makes for you is a coordinate, and that coordinate says 0, 2. It is not a surprise that in the previous line that we graphed, that it had a y-intercept of 2. Do realize that that right there is a y-intercept. So what I'm trying to say is when you want to find a y-intercept, what you really do is you set the x equal to 0. And this is the kinds of understanding that the ACT also checks to see if you know it. They're not really interested in you just graphing a line. They now think that that's more of a basic thing to do anyway. All right? So when y is equal to 0, so you restart this process. You say, let's see, negative x plus 3y is equal to 6. But this time he's saying y is equal to 0. So think about it. 3 times 0 is going to give you 0 there. So now you have an equation that basically says negative x is equal to 6, right? So if you solve for x this time, you'll end up with x is equal to negative 6. So what we're saying is when y is 0, x is negative 6. So write that as a coordinate, but be careful. The x coordinate goes right here, and the y coordinate goes over here. So now we actually have an x-intercept, and that's something that the slope-intercept form does not focus on, right? It doesn't focus on that. So now let me show you how would you graph this until still tell a slope about it, right? Because we already have essentially the y-intercept, right? So if you're wondering why are you graphing the same line again, it's because there's a purpose for it, all right? I want you to see how it comes together. So first I'll go to the y-intercept, 0, 2, right? And I'll go ahead and I'll say this is my 0, 2, and I'll make a dot right there. Then I'll go to the x-intercept, which is somewhere over here. So this is at 2, this is at negative 6, and I'll make a dot right there. And then what I do is I go ahead and I sketch a line between those two dots. And so I've got the same line essentially as I had before. And given 2 points, right? We have 2 points now. We have 0, 2, and we have negative 6 comma 0, guess what? You can take these 2 points and you can make a slope out of them. So 0 minus 2, negative 6 minus 0, negative 2 over negative 6, and you end up with a slope of 1/3, which is the same thing that you had realized before. If, again, you understand this method, it is a lot more rewarding than just knowing how to turn from a certain form into slope-intercept form. All right? And essentially, I would say these questions are pretty much all the same. There's a few anomalies. You know, if you guys take a look at number 84, if you take a look at number 86, you know, in number 84, realize that if y is equal to negative 1, what that's really saying, and we discussed this in the previous lecture, is what it's basically telling you is if y is equal to negative 1, you essentially have a line that is always going to be going across as y is equal to negative 1, right? And so if you ask me what's the slope of this line, the slope of this line, as we discussed before, is 0. What is the y-intercept of this line? The y-intercept of this line is equal to negative 1, right? Because y is equal to negative 1. And they asked us to graph the line. We already got a graph there. Number 86 says x is equal to 2. Why not? Well, in number 86, if x is equal to 2, that's basically a what kind of line? It is a vertical line, right? So make a quick graph. Go to where x is equal to 2. And when x is equal to 2, just essentially make a line right there, right? We're going through these really quickly because I know you guys are pretty good with lines. So that's where x is equal to 2, all right? And now when you need to find the slope, the slope of a vertical line is undefined. And the y-intercept, right? Because they said find the y-intercept of each line. This doesn't have a y-intercept. It never intercepts the y-axis. It has an x-intercept, but it doesn't have a y-intercept, right? So that's number 86 for you, okay? All right, let's go to the next skill. And this time what we're going to do is we're going to find the intercepts of the graph of each equation, and then we're going to graph the equation. And the whole purpose of this is really the same as the last question. It's just to make sure that you know how to use the intercept method. Okay, that's why we're going through these. So what we'll do is we'll try some of the more interesting ones. So we'll try number 98 over here. We'll try number 100, and we'll look at 102 as well. Okay, so really quickly, number 98 says if x minus 2/3 y is equal to 4, right? And they want us to use the intercept method. So because it says find the intercepts of the graph and then graph the equation. So really quickly, what we did in that last example is we said using method 2, when x is 0, this becomes x minus 2/3 y is equal to 4, and basically that part is 0, right? So now go ahead and solve this. You have the equation that says minus 2/3 y is equal to 4. If you need some help understanding how to solve this equation, basically you need to multiply on both sides by -3/2, right? It's the multiplicative inverse. And when you multiply on both sides by -3/2, the 3's cancel out, the 2's cancel out, the negatives become positives, and you're basically left over with a y is equal to 4 times -3, which is -12, and -12 divided by 2, which is -6. So here is your y-intercept. In other words, 0, -6 is your y-intercept. All right? So when x is 0, your y is -6. That's how you put that thing together. Okay, let's go to the other way to do it. Now we're going to write down y is equal to 0. Not the other way to do it, but the other part of this question. So y is equal to 0, and this time in the expression equation x minus 2/3 y is equal to 4, what you're going to do is you're basically going to turn this into 0. And this one is not much to solve, honestly. You basically end up with x is equal to 4. And so since x is equal to 4, you can say, well, this is 4, 0 is the x-intercept, right? So now that we have all of our intercepts and everything like that, you basically make a really quick sketch, right? You make a quick sketch of these two intercepts, and that's all they really want. They don't need you to find the slope of a line, but remember, if you needed to find the slope of a line, that's not that hard to do. Just take the two coordinates that you have and find the slope of the line. So let's assume this is 4 and this is -6, not necessarily drawn to scale. And we're going to make dots, coordinates, sorry, at both of those points right there. And then we're going to make a line that goes up this way. And so once again, we have completed this exercise. Okay, so it's very handy to use the intercept method, especially when things look like they're in the standard form. All right, let's take a look at number 100. Number 100 says negative 0.3x. All right, let's write this down. So negative 0.3x plus 0.4y is equal to 1.2. And really quickly, just go ahead and turn x is equal to 0. And if x is equal to 0, you're looking at it. Just turn this whole thing into 0. You end up with 0.4y is equal to 1.2. And if you go ahead and you divide on both sides by 0.4, you're going to end up with an answer that says that y is equal to 3. All right? So now we have the y-intercept. The y-intercept is 0, 3. All right? Remember, when you set the x equal to 0, you're solving for the y-intercept. When you set the y equal to 0, you're solving for the x-intercept. Now, you do the same process again, but this time, you go ahead and you set the y equal to 0. Setting the y equal to 0, it basically frees up this x, and you have negative 0.3x is equal to 1.2. And go ahead and divide on both sides by negative 0.3. And this time you end up with y is equal to positive 4. All right, sorry, negative 4, right? And so, I apologize, I made a small little error here. X is equal to negative 4, right? So then you can say that the coordinate is negative 4, 0. And of course, you know how to graph a line, so I'll leave that alone. All right. Number 102, it says find the equation of the y-axis. So this one's interesting. So your y-axis is basically, well, here's your x-axis, right? And here's your y-axis. So pretend that you had a line that was running straight down the y-axis. What would the equation of that line be? Right? So if you had a line that was running straight down the y-axis, what is the equation of that line? If you don't understand what I'm saying, think of this previous problem that we had a little while earlier in number 86. When there was a vertical line that was running down 2 on the x-axis, we said x is equal to 2. Well, now you have a vertical line that is running down the y-axis. Think about it. X is always equal to 0 there, right? So the equation of this line is therefore x is equal to 0. All right? So that's just a small little bit to understand there. Okay, now what we're going to do is it says find the equations of two lines are given. Determine if the lines are parallel, perpendicular, or neither. Even though there's only 4 questions here, this is a highly important skill that you need to have and understand. Okay, so basically what you need to do in these cases is you need to look at the slope and you need to look at the intercept. All right, and one thing I'll remind you from the previous lesson is whenever two lines are parallel, they have the same slope. Whenever they are perpendicular, the slope is the negative reciprocal. All right, so basically flip that thing over and change its sign. That is what we mean by a negative reciprocal. And of course, if neither one of these happens, then these lines don't really have any kinds of relationship in that sense. All right. So number 104 says that y is equal to 1/2 x minus 3, all right? So the slope of one of the lines, let's say the slope of line 1, right? If this is line 1 and this is line 2, the slope of line 1 is what? Is 1/2, right? Because it's an mx plus b format. The slope of line 2, right? The slope of line 2 is -2. Now, they clearly are not the same slopes, right? So M1 is not equal to M2, right? So these are not parallel. So they can't be parallel lines. Now let's take a look at if we can flip one of them over. Flip either one over, right? Doesn't matter. Flip either one over change its sign, and see if it looks like the other one. So let's take the second one, right? If you take -2 and you flip it over and change its sign, here is what that looks like when we say that, right? That becomes a half. And guess what? That is the same slope as the other line. And what that tells you is therefore the relationship between M1 and M2 is that M1 is perpendicular to M2. All right? So that's the first question that I wanted to try with you. Number 106, right? Number 106. Now you have a slope of line 1, which is equal to -2, and you have a slope of line 2, which is equal to -1/2. Same exact process. Take either one of them and flip them over. Okay, how about I take this one this time? I take the second one, and I go ahead and I flip that over and I change its sign. Mathematically, what that looks like, by the way, is this. Okay, whenever you want to flip over a fraction, this is how you make it look. Okay, whenever you want to flip anything over, 1 divided by anything, right? And so this is going to become -2 with the negative outside, which becomes a 2. Now take a look at these slopes. The slope 2 is not the same thing as -2. In other words, this was a trick question, and there is neither relationship that is existing between those two lines right there. Okay. Number 107 through 110 are basically calculator inputs, and it's so important to be able to look at a line and be able to tell what's happening on a calculator's input. And so we'll take a moment as well, if we get some time in this lecture, to try drawing some of these in our calculators. Now let's take a look at number 110, right? The question says, write an equation of each line. Express your answer using either the general form or the slope-intercept form of the equation of a line, whichever you prefer. The general form, I believe, is also known as the standard form. Okay, so I believe this is the standard form as well. Here is what I can tell you. Those two dots that I just made, those two coordinates that I made, must be -1 and -2. Now, if you're looking at it as to how exactly do you figure that out, you have to look a little closely, and you'll notice that there is these little notches on the axis. But more than that, notice how the axes have been labeled. So it's telling you that on this calculator's output screen, -3 to 3 is the x-axis and -2 to 2 is the y-axis, right? So having said that, basically you have a line that's going exactly through -2 and then through -1. So the whole purpose of this exercise, it's not like you're learning anything new here. It's just you're looking at a different input as opposed to the nice white and blue that they've been drawing in the book for you so far. Okay, so what you'll say is, all right, there's two coordinates. The first coordinate, -2, 0, right? And the other coordinate is 0, -1, which is basically the y-intercept, right? So take these two and create a slope out of them. So m is equal to -1 minus 0 over 0 minus -2, which gives you -1 over 2. So the slope of this line is a -1/2, and the y-intercept is right there, right? It's already 0, -1. So you can go ahead and create an equation of this line. If you're using y equals mx plus b, you can say y is equal to -1/2 times x minus 1. And so that's a perfectly good equation of this line over here. If you say, no, I want to put it into its standard form, okay, and I would recommend that you get used to this, please, is basically in a standard form. Okay, in standard form, you cannot have fractions. Okay, you can't have fractions, you can't have decimals. They need to be integers, right? So if they need to be integers, basically what you got to ask yourself is, how do I make this fraction that we're looking at that says -1/2 x, right? Because it says -1/2 x minus 1. How do I make that -1/2 become into something that's an integer and not a fraction? It's a very simple process. Basically, just multiply the entire equation by 2. because if you were to multiply a half by 2, it would give you 1, i.e. it would get rid of the fraction. And it's not a surprise. I mean, the 2's will cancel and it'll give you a fraction sort of a thing, right? Of course, there's a negative there, so this will show up as a negative. So when I multiply the entire equation by 2, this becomes 2y is equal to negative x and then minus 2. And then finally, the last thing that you need to do to turn it into ax plus by is equal to c format, right, is basically move this over to the left side. So it becomes x plus 2y is equal to negative 2. And now this is in the other format of a line. Here's what we have. It says the annual fixed costs for owning a small sedan are $1,289. So what you want to do is you want to highlight where it says fixed costs, right? And so the fixed cost, all right, is equal to $1,289, all right? Now, assuming the car is completely paid for, the cost to drive the car is approximately $0.15 per mile, okay? So the cost to drive the car is approximately $0.15 per mile. All right. So it says write a linear equation that relates the cost C and the number of X miles driven, right? So for this, what I want to do is I just want to pause here and I want to take a moment and go to that one last formula that we had not discussed earlier, and I want to discuss it with you. Basically, this is called the fixed variable cost equation, and you do need it in your notebook. All right, you need it in your notebook. And it basically says this. It says if you ever want to find a total cost of something, take the variable cost per unit, multiply by the units, and add the fixed cost. Okay? It's written in the format of y is equal to mx plus b, by the way. Okay? It's just the difference is we call it a v and we call it an f simply because of the fixed cost and the variable cost. Okay? So having said that, what we're going to do is we're going to go back to this part over here, and now we have a name for that $0.15 per mile, or basically 15 cents per mile. The 15 cents per mile is called the variable cost. Okay, so this is going to be called our F, and this is going to be called our V. And we're basically fitting this into mx plus b format, but we're using the variables that they're providing for us. So they tell us that the cost C, so the cost C, which is basically the total cost, is equal to the variable cost, which is V, so 0.15, right? So look, it represents slope here. And then the number of miles driven, is x, as they are telling you. And then you basically add v to it, right, which represents the slope of the intercept, basically. So 1289. And so this right here is the equation that will help you tell how much cost will be incurred by this car if it is being driven, right, a certain number of miles. Notice that the variable cost, it's going to change. It's going to change based upon how much you drive, right? However, a fixed cost, like for instance, I haven't gone anywhere for the last month or so, right? And therefore, my car is, it's still out there. I still need to pay insurance on it, right? I still need to I just recently bought the sticker for it, right? So that's like $115 or something. So I still need to pay hundreds of dollars on that car, whether I decide to drive it or not. So that's called a fixed cost. And that's the intercept in these problems. But the variable cost is the slope, right? It's the variable. It's the thing that changes based upon how much you actually use of it. So if you use a lot of it versus if you use a little bit of it, it's going to change for you how much the cost is going to be, right? So oftentimes, our parents will tell us, look, don't use too much electricity, is because in electricity, the more you use of it, the more they're going to have to pay for it. Whereas water is a little different. Usually in water, the water bill is usually it's cheaper, what that means is the fixed cost is really essentially all there is, and the variable cost is very, very small, right? You don't get charged too much. So even if you're not home, the water bill still comes at around the same amount that it would have cost anyway. And you might be saying to yourself, wait, how can that possibly be? I wasn't even home. But that's because it's a fixed cost. They were going to charge you that anyway, right? They're just like the fees and stuff that they charge. So number 130 says, here is a thought, right? Here's a thought. Which one of these equations can work with the graph that's shown on the right side? Okay, so here's a graph on the right side, and what you want to do is look at each equation and see if it works or not, all right? And we're going to try to do this as quick as possible, all right? So let's take a look at letter A, all right? Letter A. Letter A says that 2x plus 3y is equal to 6. So what I will do, all right, what I will do is I'll say in letter A that I'll use the intercept method, right? So I'll use the intercept method. And the reason why I use the intercept method is because A and B and C and D and E are all in general format. They're in the standard format. So it's easiest to use intercept method. So here goes. If I set the x equal to 0, let me just do the work on there, right? If I set the x equal to 0, 3y is equal to 6, and therefore y is equal to 2. In other words, one of the intercepts is 0, 2. Well, let me erase over that. Now set the y equal to 0, and this time you end up with 2x is equal to 6. In other words, 3, 0. Now ask yourself, does this qualify, and this right here qualify, to be 0, 2 and 3, 0? And the answer is yes. That does work for you. Notice how they didn't put numbers on there, right? They're just saying, could this work or not? It certainly could, all right? So letter A is correct. All right, now let's try letter B. Same exact logic. You just have to do these as quick as possible. Using the same intercept method, if I set 2x equal to 0, I end up with negative 3y is equal to 6, and therefore y is actually equal to negative 2. Automatically, you should throw that out and be like, yeah, that's not going to work. But just to be on the safe side, 0, negative 2 is my y-intercept. Now ask yourself, what is the x-intercept? And remember, to find the x-intercept, you set this part equal to 0. So 2x is equal to 6, and therefore x is equal to 3. So 3, 0 is the x-intercept. Now take a look at the graph and see why that doesn't actually work for us. And the reason why that won't work is because 3, 0, it makes sense. In fact, it was present in the last question too. So 3, 0 makes sense, but 0, negative 2 does not make any sense. This is clearly a positive y-intercept and not a negative y-intercept. And so option B does not work for us, okay? Then let's try option C. So 3x plus 4y is equal to 12. First, let's set the x equal to 0, and let's solve the equation 4y is equal to 12, and you'll very quickly get the answer that y is equal to 3. So you end up with 0, 3 as the y-intercept. Then start the whole process all over again. This time set the y equal to 0 and solve the equation 3x is equal to 12. And if 3x is equal to 12, then x is equal to 4, so 4, 0. Again, ask yourself, does that make sense? Can this point over here be 0, 3, while this point right here is 4, 0? And it certainly does qualify. Okay, it'll work for you. So those numbers work, and so we give that a point right there. All right, let's go to letter D. All right, letter D and letter E, they kind of go hand in hand. Letter D says x minus y is equal to negative 1. I set x equal to 0 and I get the equation negative y equals 1. Therefore, y is equal to negative 1. So I have my y-intercept 0, negative 1. All right. Now let's repeat that process, and this time what we'll do is we'll set the y equal to 0, and we'll solve for the x, and when we solve for the x, that's a pretty simple one. X is equal to 1. See how quickly I'm doing these, right? So the x-intercept is 1, 0. What's the matter with this question is if the y-intercept is a -1, that line is going positive y-intercept, not a negative y-intercept. And so we throw out letter D and say, yeah, that's not going to work for us. All right. So now we're going to go to letter E, and letter E says that you have x minus y is equal to -1. Well, first set the x equal to 0, you get negative y equals -1. Therefore, y is actually equal to +1. Look at that, right? So 0, 1, it actually works for us. Now let's turn this around and let's say, okay, what if the y was equal to 0, right? Now what we would have is x is equal to -1. And that is a problem for us, right? The problem is this is clearly a positive x-intercept. They're saying that it's a negative x-intercept. So letter E does not work for us anymore. So we throw letter E out. Okay, so far we're 2 out of 5. All right, now let's keep moving. Letter F. These ones are a little bit easier because of the fact that they're an mx plus b, and it's a lot easier for us to visualize. So in letter F, notice that the slope is -2. That makes sense because this thing is sloping downwards, right? So that does make, like, it's a negative slope. M is less than 0. However, what's the problem with this is that says that the y-intercept is -1. The y-intercept, once again, is a positive y-intercept. That's a positive y-intercept. We've mentioned that 5 times already, right? So that one does not work for us, right? Because of the y-intercept issue. So I throw that one out as well. All right, let's keep moving. Now we go to letter G, and letter G says, so let me just fill this in. So in letter F, we said that m is equal to -2 and b is equal to -1, right? It's a slope of a -1/2. That makes sense. We did say that this is a negative slope. And we have a y-intercept of a +10, and that's a positive number. So as crazy as it looks, that one actually works out for us, right? So m is equal to -1/2. The y-intercept is a 10. Hey, we're good to go. All right, we'll accept that. And so now we know that letter G works for us. And finally, the last one requires very little effort. Take a look at the slope is a +1 and the y-intercept is a 4. That doesn't make sense. The y-intercept being 4, that's okay, but this is not a positive sloping line. This is a negative sloping line. So there you go. Only 3 out of the cases that you see of 8 there actually work for you, and the other ones do not. All right. So let's move forward. It says determine whether the given function is linear or nonlinear. If it is linear, determine the slope. So let's take a look at number 24. Let's take a look at number 24. And what I want you to do is first focus on these x values. So -2, -1, 0, 1, and 2. And what I mean to say by that is notice how each one of these is incrementing by a +1, right? You may have done these in middle school, by the way. You may have done them in middle school. It's just we call it something different in middle school. We call it something different in high school. Now take a look at the y values, right? So the y values are in this other column. And in this other column, what's happening with these y values is they are increasing, right? They are increasing as well. And the question is, how much are they increasing by? They seem to be increasing by 4 every single time. And so when you notice that the y's and the x's are increasing by the same amount every single time, this is a line, right? And specifically, it's a line with the slope of 4 divided by 1, because you got to take the rise and divide by the run, right? So the change in the y's over the change in the x's, and so you have 4 over 1 as the slope of the line in number 24. Okay, number 28. All right, number 28. Notice how the x's keep incrementing by a 1, right? So we get that. Each one of these is incrementing by 1. But then again, all the tables have the same thing. But remember, that's not enough evidence yet, right? Now take a look at all of the y's. the first set of y's increments by 1. The next one increments by 3. The next one increments by 5, and the next one increments by 7. That, although it's a pattern, is not the one we were looking for, because this column right here, every single time, the change in the y's is not constant. All right, it's not constant. And so what we're going to conclude is number 28 is not linear. Okay, it's not linear. It couldn't possibly be a line, because in a line, all the numbers in the right column need to be the same, and all the numbers in the left column need to be exactly the same as well. All right, number 30 is a application question. Now, just a small little side note for anybody who doesn't understand function notation. Function notation is really, it's really y. Okay, these are really y. It's just when you come to the next level of math, we stop saying y is equal to things. We say f of x and we say g of x. So that's how that's read. That first one is read f of x, and the second one is read g of x. More than likely you picked this up in Algebra 1, but if you didn't, I just want to let you know that when you hear y is equal to f of x, they're just saying that don't worry about this notation. It's just the same thing as what you learned in middle school as y, right? And when they say y is equal to g of x, that's, again, nothing to worry about. It's still y. But if you realize the benefit of having an f of x and a g of x system is you can tell people, look, I have two different functions. I have two different lines here. But if you keep saying y is equal to something, people will get confused. They'll be like, which line are you talking about exactly, right? So it's just a way of how we look at things. All right, so I'm going to go through a handful of questions here with you just to make sure that you're able and you're comfortable to solve these problems. So letter A says, solve f of x equal to 0. Okay, solve f of x equal to 0. Now, what does that mean? Go to the equation that says f of x, right? It says f of x is equal to 3x plus 5. It's a lot simpler than it looks. So if f of x is equal to 3x plus 5, all you do is you solve 3x plus 5 equal to 0. That's all that stands for. And so you'll end up with x is equal to negative 5/3. And it's just a matter of notation. That's why I'm going through these with you guys. Now let's take a look at letter B. Letter B says solve f of x less than 0. So this is back to our lesson on inequalities. Now take 3x plus 5 and set it less than 0 and solve this inequality. For anybody who's, done inequalities, which you guys have certainly done a lot of, there's not much different how you solve an inequality as opposed to how you solve a line. It's pretty much the same thing, all right? So there you go. X has to be less than negative 5/3. Now letter C, it says solve f of x is equal to g of x. These are just instructions, all right? So you go ahead and you take g of x this time. So here is your g of x, and you set it equal to your f of x, all right? So take the equation for f of x, which is 3x plus 5, and take the equation for g of x, which is negative 2x plus 15, and set them equal and solve them. So I'll bring the negative 2x over here. I'll bring the 5 over there. So you'll have 5x is equal to 10, and x is equal to 2. Now, more than that, I need you to know, what does that even stand for? Okay, what does that even represent exactly as far as our understanding of mathematics is concerned? Listen, whenever you have to set two functions equal to one another, so let's take f of x. All right, let's take f of x and graph it. So you know that it's got a y-intercept that's a positive y-intercept because that says 5. And it's got a slope of 3, so it's an upsloping. This is just a very rough and a crude sketch for you. So here is your first line. And you see the benefit of writing that is you don't have to write down its whole equation. You can just say that line is f of x. Now let's take a look at another one. The other line has an even higher y-intercept. So what I'll do is I'll give it some more space here, right? I'll give it some more space, right? And its y-intercept is a positive 15. Very good. So I'll go all the way up to positive 15. Let's suppose this is positive 15. And it has a slope of negative 2, meaning this one is going down, right? From where it is, it's going down. So I make this second line, right? So I make this second line, and it looks like this right here. Now, remember, lines continue on in both directions. So one line won't miss another line, okay? As long as they have different slopes, they'll intersect at some point. So now, what you just did, when you said f of x is equal to g of x, what that really means is where that function f of x intersects that function g of x. So find me the intersection point there, which is right here, right? That's what you just solved for. You just solved for the fact that x is equal to 2 at that intersection point. So when x is 2 on the x-axis, that's where the two functions meet. So this letter C, one of the reasons why we do it is for you to realize that when you take two functions and set them equal to one another and solve them, that's actually finding the intersection point of them. All right, letter D. All right, letter D says solve f of x is greater than or equal to g of x. So here it is. 3x plus 5 is greater than or equal to negative 2x plus 15. And when we try to solve this, this becomes 5x is greater than or equal to 10, and therefore x is greater than or equal to 2. Now, once again, you got to make sure that you understand what this stands for. All right, that the understanding is far more important than anything, right? So we know that this is f of x, and we know that the other one is g of x. What does it mean when you say greater than or equal to? What does that even stand for, right? Greater than on a graph, greater than on a graph visually means it's above. And less than means it's below. So when they say that f of x is greater than or equal to g of x, what they're really trying to imply is the graph of f of x rises above, right? It's above the graph of g of x. So let me show you, all right? I have graphs of f of x and g of x very clearly labeled for you. Let me extend that green line for you a little bit. And the solution to the inequality that we just got was x is greater than or equal to 2. All right, so what does that mean? X is greater than or equal to 2. Well, take a look at what happens after 2, right? So let me just kind of take a look at all this area right here. All of this area. Here, let's zoom in a little bit. So in all of that area, let me get rid of this. I don't think we need it. In everything that comes after 2, right? So everything that's after 2 on the x-axis, after 2. Notice that the function that's called f of x, all right, this function right here, is above the function that's called g of x, which is below, right? So f of x, the green line, is above the blue line as long as you're talking about everything that is greater than or equal to 2. And as soon as we talk about the other side, well, what happens now? Notice that g of x is above and f of x is below. So that's the whole point of that question that we just solved. The understanding is far more important. It's far, far more important than anything in a problem like that over there. Okay, and finally, letter E says graph y equals f of x and g of x and label the point that represents the solution to the equation f of x equals g of x. I hope that you understand that we just did that entire question in speaking about it. But one thing that I would like to again highlight is when they say highlight the point or label the point where f of x equals g of x, that's a very special point that's right there, okay? And we know that x is equal to 2 there. And if you want to find out what y is, just plug into either one of the functions. Here's what it means to plug into a function. You could plug into f of 2, or you could plug into g of 2. It just means wherever the x's are, just change them into 2's. And you should get the same exact answer. In the top one, you'll end up with 3 times 2, which is 6, plus 5 is 11. And in the bottom, you have negative 2 so times 2 is negative 4, plus 15 is also 11. In other words, that coordinate is 2 comma 11 right over there. 40 says supply and demand. All right, so it says suppose that the quantity supplied S and quantity demanded D of hot dogs at a baseball game are given by the following equations. So here is the supply equation. Here is the demand equation. Now the thing about supply and demand is for instance, if you were to increase the supply of something, right? Like for instance, right now, currently, the price of gasoline is incredibly low, right? It's incredibly low. So when you increase the price of gasoline, people want to buy more. We get that. But guess what? Suppliers don't really want to supply much. At a low price, they're not going to make much money by selling it. So they don't really want to supply, right? It's a long story, but right now Saudi Arabia knows that, and they're just doing it the other way because they're trying to drive out their competition. Now, the other situation is demand. So demand, the way that works is if you increase the price, people will want it less. But if you decrease the price, people will want it more. Okay? So that's just a little bit of supply and demand for you. By all means, you can watch a video on it and see, what is supply and demand. It's a very interesting concept, honestly. It's from economics. So in number 40, letter A says, find the equilibrium price for hot dogs at the baseball game and what is the equilibrium quantity. All right, so first off, to find equilibrium price will happen where the supply of something is equal to the demand of that thing. All right, and so as far as you're concerned, that's essentially the same thing that you did in that previous exercise, is you take the supply equation and set it equal to the demand equation, like this over here. And then when you try solving for a price, you add 1,000 on both sides and you subtract 2,000 on both sides. So like this right here. And so P is equal to 3. Oops, sorry. P is equal to $3, right? So it's at a price of $3, the suppliers are willing to sell it at $3, and the demand is willing, sorry, the people who demand, the people who are consumers, sorry, are willing to buy it at $3. So that's called the equilibrium price. Now it says, what is the equilibrium quantity at that point? All right, so then you can take P is equal to 3 and you can plug it into either one of the equations. You can plug the 3 into the supply equation, or you can plug it into the demand equation. So that's the really neat thing. Well, let's go ahead and do both of them. Negative 2,000 plus 3,000 times $3 is going to give you negative 2,000 plus $9,000. And so the amount of the quantity of supply is going to be 7,000 hot dogs. Right? So 7,000 hot dogs. If you were to put the same $3 into the demand equation, it would say 10,000 minus 1,000 times 3, and guess what? That again gives you 7,000 hot dogs. And so what I'm really trying to say to you is if you were to graph the supply equation and graph the demand equation, the intersection point of that in economics is called equilibrium. And more importantly, this is why you need to know what an intersection point means on a graph. It just has so many different meanings in life and in higher level math and different courses really. In this case, the intersection point is that equilibrium quantity. Now, letter B says determine the prices for which quantity demanded is less than quantity supplied. And letter C says what do you think will eventually happen to the price of hot dogs if quantity demanded is less than quantity supplied? I leave those two to you. I don't necessarily need to go through them specifically. The important one was letter A that I needed to make sure that you're comfortable with. All right. Number 50, long distance. So again, these are all applications, believe it or not, in a different lesson, but you can all get them all figured out just in one lesson, quite honestly. And we'll be done in about 5 minutes here. It says a phone company offers a long distance package by charging $5 plus 0.05 per minute. Now, this right here, the reason why I go through it with you is because it is essentially the same thing as y is equal to the variable cost plus the fixed cost. And here is how. It says write a linear model that relates the cost C. So there you go. There's the cost C in dollars of talking X minutes. So what we're going to do is we're just going to look at these two numbers that you've been provided and figure out which one of these is like a one-time thing. You only have to pay it once and that's it. And which one will go up based upon how much you use it. Right? So think about that. All right? And the answer that you should have is this should be your variable cost, and this right here, the $5 should be your fixed cost. Is they're going to charge you $5 whether you don't even speak on your phone or you speak all the time, right? So the $5 goes right here, and the variable cost goes in this spot right here. So your equation is C is equal to 0.05x plus 5. So that is letter A. Now letter B says, what is the cost of talking 105 minutes and then 180 minutes? We'll just do one of them, right? So if you want to find out how much you're going to have to pay for 105 minutes, first off, here's how you write it. You write C of 105 is equal to 0.05, 0.05, and you plug in 105 into the x. That's all you do, all right? And then you basically plug this in your calculator, which you guys are pretty good at doing, and it'll tell you how much money you're going to end up paying for talking long distance based on the fees they've given you. Number 54 says, which of these following functions might have the graph shown? All right. And notice how this exercise is so similar to one that we've already done, right? So I just want to run you through it and make you realize that you already know how to work with linear functions. Even though linear functions are talked about separately than lines, they're essentially the same thing. All right, they basically have the same connotation, very slight differences that you notice though. All right, so let's take a look at letter A. In letter A, it gives you a slope of 3, because that's clearly in slope-intercept form, and a y-intercept of 1. Now ask yourself, could this line that we're looking at possibly be having a slope of 3 and a y-intercept of 1? We get that it has a positive y-intercept, right? We're okay with that, right? It almost seems like the same graph that we saw a little while ago, and we get that it has a positive x-intercept too. And we also know that it's got a negative slope. Well, the problem here is the letter A is saying that it has a positive slope, so not going to work for us. All right. Letter B, it says that you have a negative slope, so that's working for us. So a negative slope, we're good with that, and a positive y-intercept, and so as you guessed it, letter B is going to work for you. Letter C, this one's very important. This is perhaps one of the main reasons why I do this exercise. Letter C says h of x is equal to 3. If that's bothering you, think of it like this. Y is equal to 3, right? So if you had a line that said y is equal to 3, right? What does a line, so this is the fourth or fifth time we're going through this. So if you have a line that says y is equal to 3, and in this situation they call it h of x is equal to 3, well, that clearly does not look like the graph that we have. And so this has a y-intercept, but its slope is 0, right? So that's not going to work for us. The line that we're looking at clearly has a negative slope. So we're going to cross off letter C. That can't possibly belong to this graph. All right, go through a couple more and try them by yourself. And, very quickly you'll come to that conclusion that D is, obviously it's not going to work for us because of that y-intercept. And E is not going to work for us. Actually, E should work for us, right? So E should actually be good to go. And so there you go. We have it as number 54 there.